I wanted to push on through was because section 4 is called the second derivative test, which is exactly like the first derivative test. And so it is a great way to review the first derivative test, which some of you will need. So, obviously the second derivative test will be using the second derivative. I don't think we've really done much with the second derivative at all, other than sometimes find it. I don't think we've actually talked about what it stands for, maybe a couple times, but not like actually as a lesson or homework. Is that correct? Okay. So you guys 100% should know that the second derivative is the derivative of the first derivative. And what that is trying to tell you, so derivative means how something is changing. So if you're taking the derivative of slopes, it's trying to tell you how the slopes are changing. That's what the second derivative means. And if slopes change, like say, let's draw 0, right? Slope is 0. If our slopes start to get bigger, so 0, any positive slope would be bigger. I don't know, quarter, half, 1, 3/4, 2, no. I like how 3/4 was bigger than 1. We'll call that a slope of 2, 3, whatever. And so if you draw a bunch of slopes where the numbers get bigger, then you can easily see it curving upwards. Like those slopes would be the tangent lines. And then this green line would be the function that those tangent lines would kind of follow. So that would be a positive second derivative. So sometimes you'll hear it being called curving upwards. It does actually have a name, right? So the curvature of a function is called the concavity. I know it's up there. I don't know where the definition of concavity is. Is it below that?
Yeah.
Oh, all right, perfect. So, but anyway, concavity is just how much it curves. So if you have a second derivative, yeah, whatever. If you have a second derivative that is like 2, this one is actually relatively common because this is x squared. So y equals x squared. First derivative would be 2x, second derivative 2. So this is telling you how fast something curves. And so a normal parabola has a curvature of 2, which is quite a bit. If you had a larger curvature, like say, let's say you had 8x squared, that would have a curvature of 16, which would curve super fast. It'd be a very skinny looking parabola. And the curvature numbers can go down, obviously. This would be a curvature of 1. I suppose I could have just gone to a blank page, that would have been easier. Curvature of 1. Curvature of a half would be a very wide, very slow curve. A curvature of 0 would mean it's not curving. That would be a flat line. So a flat line has a curvature of 0. And then you can start going into the negatives. A negative curvature just means it's going to curve downwards. So it's the exact same thing as upwards. The numbers represent the same thing. The bigger the number, the steeper the curve it is. But positive just means curving upwards, negative downwards. So in my head visually, this is usually what I picture. but the part that gets most people sort of confused is you're generally never going to have an entire curve. Because the curvature changes constantly throughout a function. Unless it's a quadratic, a parabola. A parabola is the only function that has uniform curvature. And that's just a basic parabola, not even like the rest of the parabolas would still have some curvature. Cubic. A cubic function, like in your head, you can picture the S, right? So a cubic function has curvatures, two different types. The negative half, whatever you want to call that, that would be negative curvature right there. And so as long as something is any portion of a downwards U, it can be just a little section, like that, that would still be downwards U negative concavity. As long as your section that you are looking at matches any part of a downwards U, that's negative concavity. It's going to be positive concavity if any portion of your curve matches any part of an upwards U. So, negative, positive. And then they have a special name for it. They have a special name for right there. A location where your function changes concavity. It's called an inflection point. I think it's on page 2, page 1 somewhere. Now, frequently, I will accidentally call it a flex point. And I say accidentally because most textbooks used to call it a flex point, which is just a short name for inflection. But AP is pretty rigid on the fact that they will always call it inflection. So whenever your function changes concavity from negative to positive or positive to negative, they call it an inflection point. Can't imagine why people get really bad grades on things and don't understand why. Get off your phone. Have some self-control. Spencer, I was going to call on you, but then you're just sitting on your phone. I was going to let you pick the next expert. I don't know if I should.
I'd rather.
Okay. Because kind of an expert sits on their phones or in the notes. I don't remember how we picked it last time. I think we rolled.
Yeah.
Oh, yeah, but you made it up. Yeah, you made it up.
It was like you asked Siri.
Yeah, you asked Siri how many should pick a number.
No, I didn't ask Siri. I asked Google. I don't like Apple.
You asked them.
Yeah, I don't think Google actually has a name for it. It's just Google Assistant.
You just say
You asked.
Yeah, you just want to.
Random number from
Good job.
1 to 25.
Oh, we only have 25.
Yeah, this class is small.
Am I 25?
My VPN just told me that Google was malicious. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Izzy, you are our new expert. Now, the expert for the second derivative test. Spencer, can you remind her what a critical number was?
When the derivative of the function equals 0 or is undefined.
Okay, we have to clarify that now. When the first derivative is equal to 0 or undefined. Because now that we're using a second derivative, we've got two derivatives. Okay. Before I even tell you what you're the expert of, can you predict what the answer is going to be?
Of what?
Spencer, tell her the first derivative, critical numbers.
When the first derivative equals 0 or is undefined.
Can you tell me what your answer is going to be before I give you the question?
Is it the second derivative is equal to 0 or undefined?
Perfect.
I got it.
Yep. So these are going to be called possible inflection points, and that is when.
The second derivative is equal to 0 or undefined.
Perfect. So it's not like you're going to be memorizing more stuff. We're actually going to be finding the exact same information in the second derivative test that we did in the first derivative test. They stand for different things, but we find the exact same everything. We make a table exactly like the first derivative test. But the table represents curvature. Instead of increasing, decreasing, it stands for concavity or curvature. That's what we're going to end up doing in the second derivative test. So, there's going to be details and whatever. I wanted to show you this first, because that's basically what we're figuring out when we look at a second derivative test. We figure out where a graph is curving downwards or upwards, or possible inflection points would be that black point right there. Now we're calling them possible inflection points because you might have an asymptote. An asymptote will act like an inflection point, but it's not actually a point, and so it's not an inflection point. So we will have to figure out if something is an inflection point. I will just tell you that we do not call them possible. We call them possible inflection points, but we're all too lazy to write that much information down all the time. We abbreviate it as PIPs. Possible inflection points, PIPs. Okay, now I believe there is a problem. There it is. Okay, we are going to do this problem. We are going to do both the first derivative test and the second derivative test because I am 100% going to get you ready for the next section before we get there. Well, we need it
What is that?
because we did terrible on the test on the first derivative test. I wasn't saying everyone. I'm saying as a whole, it was definitely worse than it should have been. I thought that was going to be a test to help a lot of people out.
Last test.
Well, we feel the routine on Tuesday.
You want to, when you haven't got back?
Yeah.
You want to retake it on Tuesday?
Because I'm gonna be gone. And then I would forget everything.
Maybe.
So if I do really bad.
Yeah, we'll figure it out. Yeah, I didn't think of
None
that.
of it was explained.
Okay. Izzy, I'll let you call on somebody since you're an expert. You're going to be very involved in this section, just like Spencer was over involved in the last section.
Okay, I got my list.
Excellent. Can we go up there and start the information for the first derivative test? And let's make it nice, neat, and organized.
Wait, what do you mean start it? Like, do I just like?
Well, you don't have to do the entire first derivative test.
Oh, okay.
I mean, like, if you want, you can, but I wasn't expecting you to do the entire thing, because it's a lot of stuff. Okay, good, we need the first derivative to do that. Okay, now, what do we do with the first derivative to start making that table,
Wait, I don't know how you want me to organize this.
so that things aren't in random places? Like if you would have written it next to it, that's fine. If you wrote it below, that's fine. Some people are writing things in random corners on their problem and there is zero organization.
Okay.
No, this is perfectly fine for organization, except for the way you wrote your answer.
Route one is one.
Yeah, you solved it correctly, there you go.
Okay.
Okay, now, I'll let you keep going if you want, I'll let you pass it off to somebody if you want.
Well, am I finding like,
So now you need to set up the number line information.
so
Oh,
am I finding?
okay, you're not wrong, but we need that space.
Oh, I'm so confused. Am I finding where it increases and decreases or like the
Yeah.
extra?
Yep.
So then,
Okay, good, so you put your critical numbers on the number line. And while she's writing that, I will say, you're not supposed to put other random numbers on the number line. You only put the critical numbers. People were writing random numbers. Okay, so what you're doing right there is, what?
testing where it increases and decreases?
Okay, so you were picking a number in each section to test in the first derivative. Now, I want to highlight the fact that she wrote f, oh, what the heck? She wrote f prime next to each one of those. Some of you were just writing 0 equals plus. That means nothing. If she writes f prime, then I know she's putting it into the first derivative. There's more than one equation, so you have to say what you're doing. And again, in your homework, I don't care what you do. It's your homework. You need to read it yourself. But if I'm trying to follow your work, I have to know what you're doing. No, you're doing great. I was pausing to vent.
Wait, this is 0.
Oh, that's not right. That's not good. Why is it 0?
Oh, never mind.
Okay.
Never mind. Okay. So now do I find the external?
You mean like relative max, relative min? Yeah, that would be the next step. So it's already kind of labeled with increasing, decreasing. Yep. And so since those are labeled with an F, that means you're plugging it into the original function and the number next to it tells me what it is.
I don't know what 1/3 minus 1 is.
Oh, wait, we're
Negative 2/3?
negative 2/3. And we won't have to label the points or anything, we'll just,
This was also negative 2/3.
yes, also negative 2/3.
Oh wait, then.
No,
this
that can't be
should
right.
have been-
That
This
can't be
should
right.
be positive 2/3, I think, or negative, wait, hold
Oh,
on.
I'm looking at the derivative.
No, this is- 'cause then
So
it would be
cubic,
negative-
negative 1 cubed is negative 1, so that's negative 1/3. Negative 1/3 plus 1, negative 1/3 plus 1 would be 2/3, positive 2/3. And then the bottom one would be negative 2/3.
Yeah.
Yep, yep, we're good. That's plenty, that's perfect.
Just like, I don't know what 1/3 was.
Before we move on, there is many ways you can organize your information that I'm totally okay with. You just have to learn to organize your information. Like some people would have this like everywhere, like no joke. Again, this isn't a joke because these were the ones I was trying to correct. They were just all over the place. Oh, that was real bad. You have to learn to write your work so that other people can read it. And I'll just say it this very bluntly. If you signed up for the AP test and you write your AP test the way that most of you wrote your tests yesterday, they won't even grade it. they're not gonna be able to read what you're doing. They're not even gonna grade it, and there's 108 points on the AP test. 54 of them are from handwritten work. And if you're throwing out 54 points because you don't feel like taking the time to write neatly, well, then that's just a bad decision.
Is it on paper?
Mm-hmm. Yep, I know they are changing some of the AP tests to computer this year. It will not be calc, there's not a chance. Half of the test is handwritten. So it depends on your handwriting, whether that's fair or not, it's not up to me. But if they can't read it, if they can't follow it, they're not grading it. So, if you paid for an AP test and you signed up for one, you should maybe keep that in mind, right? Like, it's kind of a big deal. If it was all multiple choice, well, it's a totally different story. Unfortunately, free response questions depend on you writing it, so. I apologize, I will probably be venting about this for a couple days. Because I was very excited for you guys to get some good scores and do well on it. And I was expecting that. And many of you did the problems correctly, as far as I could tell. But the problem was I couldn't tell for some of you. I have no idea where you're getting your answers from. Okay, so there's our first derivative test. This is what the last problem on the test should have looked like. And many people just wrote the derivative and then wrote the multiple choice answer. Now, I know for some of you that was probably because of lack of time or something. Maybe you went too slow on some other parts of the test and so you were just kind of writing stuff, right? That might happen too. I mean, that happens to everybody. But there were definitely people who were apparently done so early, they started doing, problems 7 and 8 because they were bored or just whatever. So they clearly had time, but just left it out. Okay, now we are going to do the second derivative test, which is talking about how our graph is curving. Who are we choosing? Somebody from other tables, not near you.
Donald.
All right.
Donald,
Hit me.
I'm not gonna hit you, that'd be just that.
That's not what I meant.
That's pretty rude. That is rude and also illegal, and I would go to jail. This isn't the 80s when I was in school. No, they did. Yeah, no, that's no joke. I was at a Catholic elementary school, and they did not do that. They hit you with a ruler on your knuckle.
I thought that was, yeah, I thought you loved it. I thought we, that was like
Nuns?
You actually got.
Yeah, nuns don't care what you
Oh, I
think.
go up there, yeah. I go up there and do it, right?
Yep, that is what I was waiting for.
It's all for show, okay.
Yes,
Make sure.
in my first grade class, if you were misbehaving, you would have to put your hand like this and
That's
then
what
hit
you
you at the edge of
Oh,
the ruler.
no. Yeah, I thought that was poker. Yeah, because remember we went to that.
No,
St. Nick's
you
Farm?
guys don't understand, this was just one generation ago.
We just sit on the stool.
Okay, good, we are finding the second derivative for the second derivative test. Good, good, good. All right, now nicely and easily, this question was kind of picked so that the equations would work out pretty easily. Now, while he's working on that, oh wait, do you want me to pause for a second?
Oh, sure.
What is he doing? What does he need to do next? Well, he did that. So what does he do with the second derivative? Or? Good, 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 very good. Yeah, I saw you writing it, it made me think of it.
Oh shoot, should I be writing this?
Oh, yeah, because you. Yeah.
Oh, yeah. Yeah, you got time. We're not doing many problems today, we're,
Looking for pets. What's it? I forget it.
okay, so 0. Now let's actually write next to it what it's gonna be called, because, I mean, we found something. It is gonna be a PIP, a possible inflection point, which is an abbreviation.
Shit.
Oh, I thought you were writing a fraction.
Oh, no.
Abbreviation, dot, dot. No.
What?
You know, do you want between?
I mean,
It just means possible inflection.
Well, I can't make it bigger?
So P dot I
Oh.
dot T dot.
I thought you meant like afterward.
Am I using the wrong word? Is that acronym?
No, it's right.
It's abbreviation or acronym. Well,
Okay.
abbreviation is,
P period, I period, P period.
yeah.
Possible inflection points.
Yes.
On
Okay.
the test, would we get points off for not doing that?
At this point, yes.
You're funny.
Because
You
everybody
get
seems to be
knowledge
looking,
points
everybody seems to be looking for loopholes in the least possible thing they can do, which is generally fine, except for people did less than the least that they were supposed to do. Okay, so 0 is the only pip.
Yes.
Now, we are going to draw, here, let me make these smaller so you have room to fit things.
All right.
No more than
Well, that's annoying.
Why don't you just erase it? I special.
Because I want this information here still. Okay, so we are gonna make another number line that represents the second derivative, and we do it next to the second derivative information so that I know the number line is for the second derivative. I feel like I'm gonna need to be a lot more detailed on telling you exactly what to do. Okay, perfect. So 0 is the only number that goes up there. All right. Now, do you want to keep going? Do you want somebody else to go?
I can keep going.
Okay. I haven't told us what to do, but what do you think we're going to do next?
Probably something similar. To
Perfect. You're going to choose a test number in each section. And so next to that number, you should not just write a random number. That number is specifically going to be used somewhere, so we write that.
Okay. We could do.
So where are we going to put that number? Oh, perfect. That's what I was trying to get at. So f double prime of -1 and f double prime of 1. And if you want to write them underneath the section, you can. If you want to write them below the number line, you can, as long as the information is labeled, you know what it's for. Okay, so again, we only need to know if it's positive or negative,
Oh, okay.
which this one's super easy to find the answer anyway, but, okay, so now we traditionally tried to write those pluses and minuses on the section so that we knew what the information was for. Okay,
Just that's just for me to look at it and see.
that's for me too.
Cool.
Do you want to call on somebody? We can just stay up there if you want, but we'll call on somebody.
Okay. Spencer.
That's fair.
He was giving me crap today.
So he wrote minuses and pluses. Now, we didn't write it on the first derivative test up there because I knew you guys had, actually, I should have made you write increasing, decreasing, because some people probably don't know what the plus minus means. What does the plus minus mean on the second derivative test? So I'll have a minus. There was like 20 people over here that just said concavity. Curving downwards or concave down. So underneath the minus sign, maybe we should write concave down. Whether you abbreviate it, whether you write the full words, as long as you're stating what it is, that's normal. I'll give you a break because writing with the marker up there is tough.
It's a little thick.
Yeah,
And
that's
this
right.
is supposed to be like what
I was about to say something snarky, and then I realized that I would have done the same thing because it's the only way you can write it then. Okay, and then the plus. Concave up, perfect. It is a little odd you write an arrow for up and down. But I like how you drew the U's so that it clarified. Okay. Spencer,
Yes.
we need, one last person.
Emily.
So, Izzy, what was Izzy the expert for?
Second derivative, when it's equal to,
Yeah, they have a name, just like critical numbers had a name.
it's the, isn't it the point?
Yeah,
You wanna talk about this?
Yep.
Name of it. Flex point, inflection point?
possible inflection point. Now, we called it a possible inflection point because we have to figure out if it actually is or not. I believe on the previous page somewhere, okay. It is there. I wrote all over it. Oh, you know what? I think it's actually on the third page of your notes. The actual definition, if I remember right. Yeah. I don't know why it was, whatever. Okay, so an inflection point has an actual criteria it has to meet to be called one. What is that?
If C, F of C.
Oh, too much. Explain it like I'm dumb, because it's probably accurate.
Okay. If it's a point on a point of inflection on the graph, then either the second derivative of C equals 0, or the second derivative of C is undefined.
So that's a possible inflection point. What is an actual, wait, didn't it say it right there? Yeah. So an actual inflection point has something we look for. So what you told me was perfect for a possible one.
Correct.
And if you want some help, we can give you some help. I'm not trying to put you on the spot like that.
Is it like in the definition, like in the positive there, or is it?
Yeah, it's highlighted, it's written kind of weird though, but, so it's like the first part.
Oh, okay, I thought it was the second part, that's what I was asking.
It's the very last sentence. It's written in paragraph format, so it's hard to follow.
It has the tangent line at the point.
Yeah, that's the part that I thought was kind of weird. It was written in there.
Yeah.
That's not actually a definition. So right after it, when it says, if the concavity of F changes from upward to downward or downward to upward at the point, if, maybe we want to highlight that, maybe that would be helpful for the notes, because the paragraph is written kind of lengthy. That's what you're actually looking for. You're looking to see if the concavity switches from positive to negative or negative to positive, because it's not always going to do that. That one was kind of tough because it's paragraph. Okay, but good. So we've got this table here. Does the concavity switch before and after 0? Yeah.
Yes.
Okay, so that tells us 0 should be an inflection point. And to find out if it's actually a point, we go with Daniel. How do we find out if 0 is actually a point on the function?
You gotta
Put it where?
answer the equation.
True, there's 3 equations though.
No,
Which one would tell us a point? One equation tells us
like the,
heights, one tells us slopes, one tells us curvature.
so like the normal equation.
The original one, F, or whatever it's called. Yeah, F. So we need to plug 0 into F to find out if it's actually a point. Sometimes you might find out it's not, like it might be a Vertical asymptote or something. So 0 would go into 1/3 x cubed minus x, which is conveniently 0. So f of 0 equals 0, and we have an inflection point at 0, 0. Nice job.
Thank you.
So what number would that have to equal to, like, it's
Any number.
any number?
If it's not a point, it would be like undefined.
Okay.
You get like divided by 0.
Yeah, so it can just be any number.
It could be any number as long as it's an actual point, like which, an actual point means you have number answers.
Oh, so does that have to be equal to 0?
No, that was actually just coincidence.
Oh.
Now, I think a lot of you even knew what this looked like before we did anything on here. It was cubic, goes up, down, up. And that's the information we got. Now, we're gonna be doing the tables and the testing this section. The next section, section 5, is when we take this information and make an accurate drawing. So I'm trying to present everything now extremely slow and thorough, because otherwise, if we just do second derivative things in this section, when we get to the next one, then we have to talk about trying to do everything all at once. So my thought process is to do less problems more thoroughly, so that you guys get used to everything you're supposed to do. Downside, they kind of take forever. What I would like you guys to do for this weekend's homework, do the full first and second derivative test on this function. Find everything you're supposed to. So find where it increases and decreases. Find relative extrema. Find intervals of concavity, which means where is it concave up, where is it concave down. Find any inflection points. Just one problem. But there's a lot of stuff, so they go slow. Now, using our thinking hats, what does this look like ahead of time? Because you guys kind of know polynomials. Should be probably W-ish. We know it's going to be upright. It's either going to be a U or a W. We actually don't know the inside information. All of the details are all of like the cubic, the square, the x, the numbers. Those all tell you what the inside looks like. So it's either going to be a U or a W. My guess is a W because it's a pretty plain equation. So we have 5 minutes left today. Wouldn't even doubt if some of you get it done in that 5 minutes. But that's, or maybe I should even speak to the fact that this wouldn't be a bad plan to start your homework. Do the things you can do in your homework, rather than waiting until all of it's done. Would it be helpful if I made homework due relatively soon afterwards, rather than saying at the unit test? Because far too many people are just putting everything off to the unit test, and then they say that's how they study, which they can, but like, it's a terrible plan, and I've said that all year. I don't want to have to do something like that, I guess. And I get you guys have 6 classes. It's part of the thought process when you guys try to sign up for your classes. The counselors used to tell you never to sign up for more than 2 AP classes at a time because of work involved. Now there's tons of people that have like 4 and 5.